Okay. So last we left off, we were talking about the imperial system or the USCS conversion, right? And so are you guys comfortable with doing those conversions using dimensional analysis? Yes, no, maybe?
We can review Lisa.
Okay, let's see. So can you guys see my screen?
Yes.
Good. So here's my question for you.
He went home. Because I'm why? Jordan.
Yeah. Yeah.
Yeah.
Okay, so if Johnny was walking 5 miles to school, how far is that in kilometers? Okay, how would I go about doing this?
You start with what's given.
Start with what's given. Okay, so what's given?
5.009.
5.00 miles. Okay.
And then you have to convert miles to kilometers.
I would have to convert miles to kilometers. Where would I find that information?
So it would be 1.609 kilometers for 1 mile.
Okay, 1.649,
No,
sorry,
0.
609
Yeah.
kilometers for 1 mile.
So then you multiply.
Okay, so what did you guys get?
Eight 8.045. So then it would be 8.05.
8.045. So what number are we using for rounding in this case?
The yeah, the 5. Wait, Miss Yanez, can you move the screen?
So how many sig figs do we have?
1,
1,
8.00. Is that 1 sig fig?
3.
Okay.
Or what does that decimal point mean? If I'm taking the time to put in that decimal point, that's telling you what?
That works. Yeah, but that works out of the screen.
Okay.
That the zeros are significant?
That those zeros are significant. So we don't have to put a 0 here, right? 50, unless we want to sit there and make those zeros significant. So by us taking that extra time to put that period and those O's there, right? Because 5 is going to be almost the same thing as 5.00, is it not? So is a $5 bill always going to be a $5 bill?
Yeah.
Okay, so 5 equals 5.00, right? It's 5. Is that correct? But the difference between the two is that these zeros are significant, where this one doesn't have zeros around to be significant because nobody knew how exact they were. Okay, so my answer should be how many sigs?
They picked one.
If it's 5.00, it's 1 sig fig.
Three.
It's 3 sig figs, right? So my answer should be 80.
5.
Are you sure?
8.04.
Why is it 4?
Oh, wait, yeah.
Because there's only a 5, so it doesn't change.
Yeah, so here, this is a 5. This is the one that's going to be determining whether or not we're going to be rounding up or leaving it alone. But then since there's nothing beyond that 5, nothing higher than that 5, because you don't have 0.000, I mean, you don't have 5000001, right? Then that means we're not going to round up. We're just going to leave it alone. Okay? Good, bad, or ugly? Okay. Let's see. Okay, so the next thing that we're going to be talking about is temperature. So temperature is measured in the US on the Fahrenheit scale. Other places measure it in Celsius, the Celsius scale. So we know that on the Celsius scale, water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. Okay, where on the Fahrenheit scale, water freezes at 32 degrees Fahrenheit, and then water boils at 212 degrees Fahrenheit. Okay, so the way that we would change Fahrenheit into Celsius is by using this equation down here. How many of you guys have your packet, your polyatomic ion periodic table packet? Everyone? No one? What? Okay, so if you guys look on the one, it's the Army, the back of the Army, it says US Army on the bottom. You guys see that? So if you look up in the third column at the very top, it actually does temperature comparison. So it'll be right here. Okay, so the way this would work is that if we have something in Fahrenheit, we just plug it into this equation, right? So if we go 212, so 212 minus 32 over 1.8. Are you guys there?
Yes.
Okay, so 212 minus 32 is what?
$180.
Okay, 180 divided by 1.8.
100.
So our temperature would be 100 degrees Celsius. Let's see if I can fix that. Are you guys there, Avenel? Getting
Dr.
a little-
Henry,
yes,
for the definition for freezing point of water for Celsius scale, that
Yes.
F is supposed to be a C, right?
that is supposed to be a C. That is correct. That's a typo. Good eye. Okay, so if we want to solve it for Fahrenheit, we just need to rearrange this equation. So if we rearrange this equation, we get TC times 1.8 plus 32 equals TF. Okay. So if we have TC is equal to 0, what is TF?
$32.
Okay. Okay, piece of cake, not too hard. Excellent. Let's move on. So in chemistry, we also use another means of measuring temperature, and that's called Kelvin. The reason why we use Kelvin is because Kelvin is on the absolute temperature scale. So at 0 degrees Kelvin, everything stops moving. Okay, so if you're at 0 degrees Kelvin, molecules aren't moving, atoms aren't moving, nothing is moving. Okay, so that's the absolute Kelvin scale. So 0 degrees Kelvin is also equal to negative 273.15. And so that's going to be used to sit there and change Celsius to Kelvin. So the way I would do that is T Kelvin is equal to T Celsius plus 237.15 to be exact, but you can get away with dropping that 0.15 because it's so small relative to the other number. Okay, so if I have 0 degrees Celsius, which is freezing, say 0 degrees Celsius, how much is that in Kelvin?
We'll have to,
273.
273 plus 0 is going to equal 273. Okay, so if it's 115 degrees outside, which is supposed to be today, like 115, depending on where you're at, how much is that in Kelvin? 115 Fahrenheit. How much is that in Kelvin? And how would I figure that out?
Would you convert it to Celsius first?
Okay, the first thing I would do is convert it to Celsius. So how am I going to convert it to Celsius again? What is that equation?
It's TF minus 32 over 1.8.
Okay, so TC equals TF minus 32. So 115, oops, over 1.8. So if we go ahead and plug in that 115 here, subtract 32, and divide that by 1.8. So what do you guys get?
$46.1.
Okay. Okay, so 46.1 Kelvin. Okay, questions, concerns, Cash? Paolas?
Wouldn't that be the 46.1 Celsius? And then you would turn it into Kelvin?
Oh, yeah, that's right. Thank you. That would be Celsius. Good catch. That's degrees C. So 46.1
And then he's gonna convert it
Celsius
Celsius. So is that what you were asking?
plus what is going to equal Kelvin?
Celsius? Yes. Also in your package.
So I'm going to add what to it? I'm sorry.
The 73.
273. So 46.1 plus 273 is 319.1 Kelvin. Piece of cake?
For Kelvin, you don't put the degree sign?
No. It's just the K. So for Fahrenheit, you put the degree sign. For Celsius, you put the degree sign, but for Kelvin, you only just put the K. Okay. Okay, so this is just basically comparing all three of the different temperature scales. And so you can kind of get a comparison of the three. So let me clear that. Okay, so let's see your skills. So if we're converting 288 Kelvin to Fahrenheit, how would I go about that process? Any ideas? Let's see, Marguerita,
Yes,
are you there?
yes.
So what should I do first?
So it's gonna be, you're gonna convert Kelvin 288. So put your given, which is 288 K.
Okay. So I'm going to convert that to what?
Fahrenheit.
So how am I going to convert that to Fahrenheit? Isn't there a step I need to do before that?
Yes. So
So wouldn't it be easier for me to convert it to Celsius? And then I could use that equation that's in Celsius to change that to Fahrenheit?
Yeah.
So how would I do that? How do I convert it to Celsius?
So it would be.
So if I know that T Celsius plus 273 equals T Kelvin. So if I have this equation, how would I use it?
You're gonna subtract it?
I'm going to subtract. So I'm subtracting 273. So 288 minus 273,
15.
so 15 degrees Celsius. Okay, so then how do I convert Celsius into Kelvin?
So then 15 plus 273.
Okay, I heard something about 15 plus 2003.
270.
So if I go, let's see. So we have Celsius, we want to get Fahrenheit. So we know that 1.8 times T Celsius
Dr. Henry, what chapter is this again?
This is chapter 3.
Chapter 3. Okay, thank you.
So if we add 15 times 1.8, plus 32, so that's going to be 59 degrees Fahrenheit.
Yes.
Okay, questions, concerns? Okay, good. Okay, what you guys are going to do now is, let's see, get in a couple of groups, fill in this table, clear the screen, fill in the table. So what we'll have you guys do is, let's see, how many people are online? So we have 10 people online, and Jessica at Avenel, just have them talk about this on a table or on the board and have them write up the answer to each group. So there should be 8 groups or so in Avenel. So there's 1, 2, 3, 4, 5, 6 empty spots. So make them groups of 6. 4, 5, 6 in Avenel. And for those at home, I'm going to put you guys all in a room together or into 2 rooms.
So you guys get in groups of 6 and you're gonna work on the table for Fahrenheit, Celsius, and Kelvin.
Okay, let me see. Groups.
No, your group is just working on everything. Oh, yeah. So you can get more practice.
Okay, I'm gonna give you guys about 10 minutes. Okay, rooms are open. Okay, let's see. Let's go with Enrique.
He's not here.
Where's everyone?
They ditched Dr. Henry.
They ditched.
Yeah.
Excellent. That's good to know. Okay. Let's see. What about Jordy? Is Jordy there?
Yeah.
Okay, good. So Jordy. So go up and write on Jessica's board. The very first one, I'll circle the one that I want written on. So the one that's blank here.
Oh, what is it? I put negative 13.
What was that? I'll put your name in there.
13.
You said how much?
Negative?
Negative?
Yeah.
Negative 15?
13.
Negative 13. Okay. Oops. Okay, negative 13. Okay, Stephen. What is it in Kelvin? Negative 25 in Kelvin. Are you there, Stephen? Okay, how about Erica? Are you there, Erica? Okay, Priscilla, are you there? Okay, then we'll get Juan. Juan would let us know, right? Let me guess, Juan ditched too, right?
Juan isn't here, but Eric is here.
No, I can't run away, Mr. Henry. Come on, you know this. Where am I supposed to go?
Okay,
I literally live in town. There's nowhere to go here. If there's no Starbucks, there's no reason. Right here? Oh, wait, this is for me. Oh, I didn't know. Okay.
okay, all right, you're gonna do the
I know
one.
where to go. Sorry.
Okay, Eric, go ahead and do this one.
Do what?
This one right here. I know I'm just spelling your name. It's,
Okay.
I can't remember how to spell your name. Is it A-R? A-I-R?
Oh,
Harry?
it's 48. Right.
It's what?
Wait, 248.
248? Okay,
Which one are you doing? You're doing K. Oh, okay. Yeah, that's 248. It says right here on the
Okay.
packet.
or you're just reading off the packet, you're supposed to figure it out yourself, right?
But you have it on the packet. It says right here, active
So
exercise.
next time, I'll remember not to put anything on the packet. I'll leave
I'm
them all
working with
blank.
what's given to me, Mr. Henry.
Oh, okay. Okay, so basically, by doing those conversions, you're able to sit there and do the calculations and figure out everything on the table. Right? You want to make sure that you understand how to do this for this coming test on the third chapter. Oh, by the way, how many of you guys completed the exam yesterday?
Like around 5 or 6 people.
Okay,
That's what they said.
okay, so let's move forward. Okay, proportionality. So a lot of times we're going to be using what we call proportionality. So a lot of equations were based upon proportionality. One of those equations is density. So If we look at density, density is mass and volume, right? It's actually mass over volume. So mass and volume are directly proportional to each other. So as the mass goes up, right, the volume is going to go up. Does that make sense? Okay. So since mass and volume are directly proportional, we can give it a constant value. Or in this case, we can call that constant value density. So by us giving that constant value, we can actually set these guys equal to each other. So we can say mass is equal to density times volume. Or we could just change that around and say density is equal to mass divided by volume. That's a D, not a P. Okay. And so there's two ways of looking at proportionality. Things that go up together, they're considered to be directly proportional. Things that go in opposite directions, they're considered to be inversely proportional. Like for instance, if we look at, the speed of light, c, is equal to lambda nu. Okay. So we use this equation here. In this situation, speed of light is the constant, lambda is the wavelength, and nu is the frequency. Well, as the wavelength goes up, the frequency goes down. As the frequency goes up, the wavelength goes down. So those guys are considered to be indirectly proportional. Okay. So this is just basically showing you exactly what we just talked about, that there's a proportionality constant that we can use to make the equations actually equal rather than just proportional to something. Okay. And then this is how they figured out about density. Okay, so density is equal to mass over volume. So the units for density is going to either be grams per milliliter or grams per cubic centimeters or pounds per cubic feet or pounds per cubic inches. Okay. So density is actually dependent on temperature. So the density of water is going to be different than the density of air. Is that correct? So, how many of you guys shower? Do you shower daily? I don't know about some of you, because sometimes I come in there, I'm like, what's that smell? So now when you shower, right? And you let the shower run for a while and it gets all steamy. So is it like walking through a swimming pool?
No.
So is the density of water vapor the same as the density of water? No, they're not. So what is the difference between the water vapor and water? What was that?
One is a gas and the other is liquid.
One is a gas and one is a liquid. So how do I change that liquid into a gas? By increasing the temperature, right?
Yeah.
Okay, so we know that density is then temperature dependent, because if I change states from a liquid to a gas, we're changing the density, right? But we know that density is always constant if the temperature is constant. If it's not changing, temperature is always at room temperature. We know that the density of water is going to be 1.5 grams per milliliter. Okay. Questions, concerns, Cash? Okay, we'll keep moving on then. Okay, so here's ice. And you can see that ice is nicely compact, nicely organized. Here's water. Well, water is going in all these different directions and everything like that. It's kind of random and all that stuff. So it's packed real tightly. So the water is a lot closer to each other than the ice is, right? And also this ice has these open areas in between the molecules. Do you guys see that right here? Oh, the spider on that. Right here, you see it?
Yeah.
Okay, so those open spots allows air to get trapped up in there. So we kind of talked about this at the very beginning. So what happens if we stick ice and water?
It
What
floats.
happens to the ice? It floats. And the reason why is because
Ice has a lower density than water.
ice has a lower density than water, because you have all of those little air pockets in there to give it that space, where water is all nicely compact. Okay. Okay, up here, we're showing you water and ice. Down here, on the bottom of the screen, you have ethanol. Ethanol is drinking alcohol. So we have a frozen cube of ethanol that's been put in ethanol. So it actually drops to the bottom because in this case, the metal is heavier or more dense. I'm sorry, not metal. The solid is more dense than the liquid. Okay. So, oops. So part of that reason is because ethanol doesn't form this nice air pockets because it's not as polar as water is. Since water has a large polarity, it's able to form those nice little air pockets, that nice little organization, where ethanol doesn't do that. Okay, so these are some densities of some of the common substances that you may run into. So like for instance, so water, the density of water is 1.0. So have you guys ever been out on a boat or floated on a piece of wood? Anyone? Okay, none of you guys been out on a boat or played in the river with a piece of wood or walked along the river or peed along the river? Anyone there?
Yes, right here.
Okay, good. So if you get a piece of wood and water, what happens?
It sinks.
Are you sure?
Floats.
Okay, so hopefully you said it floats, right? Because lumber, if you look up here, lumber is less dense than water, so it's gonna float on the water. Where something like iron or aluminum, if we put it in water, it's gonna sink to the bottom. Okay, so things that are less in density will float in water. Things that are heavier in density are gonna drop in the water. Make sense? Okay, so the mass of a 50.00 milliliter sample of methanol is 39.59 grams. Determine the density of methanol. So what am I going to use in this case?
Would we use the formula D equals M over V?
Yes, we would. Okay, what is our mass?
39.
Let's see. Minerva, what is our mass?
Oh, she's in orientation.
She has orientation.
We had orientation. Let's see. Adriana, she had orientation too?
She had a doctor's appointment.
Okay, Alyssa, okay, 39.59. And that's units or what?
Ms. Janet.
Grams. Okay, what is the volume?
Can I go? I was about to ask you. I literally got it for everything. Just get low cup 50.
50.00. How many sig figs should I have? So 39.59 divided by 50.00. That's going to equal 0.918. And that's grams per milliliter. Okay, piece of cake?
Yeah.
Good. Okay. So the density of a certain machine oil is 0.910 grams per milliliter. Find the volume occupied by 196 grams of that oil. So how would I do that? So could I start by using this equation again? But now I'm given, oops, I'm given density and grams. So I'm given density and mass. How can I solve for V? Are you guys there? How would I solve for V? So if I multiply both sides by V, so then this V is going to cancel out. And then if I divide both sides by D, so then I get V equals equals mass divided by density. So our mass is what in this case? What is the mass?
106 grams.
196 grams. Divided by 0.910. Oops, yeah, 0. grams per milliliter. So how many sig figs should I have? So I have 1, 2, 3 here. And how many do I have up here? Okay, so we're good with sig figs, so 3 sig figs. So I get 215.38. So if I'm gonna round to 3 sig figs, what should be my answer? Okay,
215.
215 milliliters. Okay, are you guys done? Are you good? Yes, no, maybe? Okay, good. Okay, so things to keep in mind. You should always be paying attention to your dimensions, right? Always figure out what's being given to you and what the question is asking you. That's usually the common mistakes that a lot of students make. And practice a lot, okay? Okay, can you guys see my slides? Hello, are you guys there?
We can see
Good.
them.
Okay, so at this point, you guys should be very familiar with chemical formulas, right? So here's an example. We have sodium nitrate. So sodium nitrate is composed of how many sodiums?
I can't hear anything he's saying.
Sodium nitrate is composed of how many sodiums? One sodium. Nitrogen, how many nitrogens? How many? Are you sure? One nitrogen. How many oxygens? 3. So we have 1 sodium, 1 Na, 1 nitrogen, and 3 oxygens. Okay. So that means that for every formula that we have, right, of sodium nitrate, we're always going to have 1 sodium, 1 nitrogen, and 3 oxygens. That's consistent. And that's what the subscript represent. Subscript is next to the element that has multiple copies, right? If there's no subscript, it's understood to be 1, meaning that there's only 1 copy. Is that correct? And you guys are aware of that, right? Good. Okay. So how many atoms of each element are in the formula unit of ammonium carbonate? So what is the chemical formula for ammonium carbonate? What's that? Ammonium. Let's see, who am I gonna pick on? Giselle. Are you there? Haley.
Yeah.
Okay, Haley, tell me about ammonium.
It's NH4.
It's NH4. Okay, let's see. Johnny. Is Johnny there?
He's not here.
Okay. Let's see. I don't have my list in front of me. Let's see. Is it Elaine? Elan? Is that right? Elan? Or no, sorry, Leanne.
What?
Leanne, tell me about carbonate.
What about it?
Give me the chemical formula
The chemical formula for carbonate?
for carbonate. Yes, ma'am.
It is CO3
So carbonate is CO3
and -2.
and a -2 charge. Like that.
Yeah.
Okay, so Haley told me that ammonium is NH4 plus, and Leanne told me that carbonate is CO3 2 minus. So how many ammoniums will I need to balance out the carbonate?
2. Another one.
I'll need another one, right? Okay, so my chemical formula would be NH4 and what would I put down here? Put a 3?
Oh, 2.
A 2, okay. And then CO3. Okay, so how many nitrogens do I have in ammonium?
2.
I have 2. How many hydrogens? How many hydrogens?
8.
8. How many carbon?
1.
How many oxygens?
3.
Okay. Okay, so when we start talking about the formula mass or the mass of a compound or the mass of a molecule, we're going to take into account how many there are. So for instance, nitrogen. What is the mass of nitrogen alone?
One.
Nitrogen is 1. So if you look at a periodic table,
-3.
did you guys look on the periodic table?
Yeah.
What is that 14.0007 at the bottom? That's what?
That's the weight, the mass.
That's the mass of that atom, right? So if I want to calculate the mass of a compound, I have to take into consideration how many of each atoms there are. So how many nitrogens do I have?
2.
I have 2. Okay, so since I have 2 nitrogens, so it's 2 times 14. It's really 14.007. So we're just gonna round it up to 14 to make it a little bit easier for ourselves because we know that the nitrogen weighs 14. And the units of mass is either AMU or grams per mole, molar mass. Okay, and I'll talk about that a little bit in a minute. Okay, what about hydrogen? We have 8 hydrogens. How much does hydrogen weigh?
1.
It weighs 1. Okay, carbon.
12.
Okay, carbon weighs 12. So 1 times 12. Yes. I heard somebody say Dr. Henry. Nobody said Dr. Henry? Okay, I'm hearing things. Okay, so how many oxygens do we have? So we have how many? 3, and it weighs how much? How much? 16? Okay. So 2 times 14? It's 28. 8 times 1? 12 times 1? And 3 times 16? Okay. Oops. So if we add them all together, let's see, that's 26 up here. So then that's 96. And we would say AMU for atomic mass units. Or we would say 96 grams per mole. Okay, piece of cake? Good. Okay, so the molecular mass is the average mass of a molecule of a compound expressed by the atomic mass. So in the case of a molecule itself, we're looking at the average mass of the molecule in the case of molecular mass. Formula mass is the expressed in units of 1 formula unit of a substance. Okay, so I'm going to tell you the difference between formula mass and molecular mass. So like for instance here. So this is carbon dioxide, that's CO2, right? This is how we calculate the formula mass or the molecular mass. The way that you would do it is by having, we know that there's 1 carbon, carbon weighs 12, there's 2 oxygens, so 2 times 16 plus 12, that's going to give me 44. And the units that we use is units or AMU, atomic mass units. Okay, so you'll see them written both ways. And so all you're doing is taking the sum of it together. Now, the molecule itself is the thing that is covalently bonded together. So in this case, this is the molecular mass of carbon dioxide. So it's 1 unit of 1 carbon dioxide molecule, where the formula mass is going to be the average of really, so that definition that we just saw is kind of like backwards. It's going to be the average of compounds coming together. Like for instance, if we talked about sodium chloride, so NaCl. So NaCl is an ionic compound, is that right? What holds it together? What keeps it a solid? What keeps it a solid when it's at room temperature? So what is holding that sodium and that chloride together? Are you guys there?
Yeah.
So what holds it together? What holds ionic compounds together? What was that?
You guys, quiet down. He's asking a question.
Boy, you guys are up in arms today. Okay, so you guys remember me talking about the good boy and the bad girl?
Yes.
Okay, what happens when you get a good boy and a bad girl together?
It turns into a good boy in a house.
What was that?
It turns into a good boy.
He turns into a good boy.
Yeah.
Are you sure?
Oh, no, it turns into a bad girl.
He turns into a bad boy?
It turns into a bad girl.
Oh, she turns into a bad girl. So do they connect? The
Yeah.
good boy and the bad girl? Why? Why do they connect?
Opposites attract.
Because opposites attract. So what's holding them together are the opposite charges. So really what's holding sodium chloride together is that plus charge by sodium and the negative charge by chlorine. Okay? So since we have that plus and negative, plus and negative, plus and negative, it's really a lattice of ionic charges that are holding things together. Okay? So in that case, we can sit there and do calculations where we calculate each of the sodium or chlorides. We don't do it that way. What we do is take one sodium, because we know one sodium will balance out one chloride. So since we know that, we take just that one sodium and that one chloride and calculate the mass of that. So sodium weighs how much? Are you guys there?
Yeah.
23.
23. Okay. Chlorine weighs how much?
35.
You said 35?
Yeah.
35, isn't it 35.45?
Yes.
Okay. I'll make that important here in a second. So if I was adding these together, it's going to equal 58.45. And that's either grams per mole or what?
AMU.
That's right.
Oh, it would be a decimal. I know that.
Okay, questions, concerns, catch? Good. Let's move on.
Why did you not round?
Why didn't we round the 45? Technically, we could round the 45, but it's 45, right? So if I have two of them, so if it's 35.45, if I have two of those, like in the case of barium fluoride, so 2 times that, that's going to give me, instead of 70, it's going to give me 71, isn't it? Or close to 71. Where if I just said it's 35, it's going to be 70. So that 1 is going to make a difference. You understand? So if I just use 35, 35 times 2, that's going to be 70, where this guy is going to be 70.9. So since that's greater than 5, we can round up, just say 71. Okay, are you guys there?
No, it wouldn't be 60.
Does that help explain it?
Kind
So
of.
in the case of oxygen, oxygen is really 15.999. Okay, so in that case, we can just round up to 16 because it's so close, right? Regardless of how many you have, it's so close to 16, so it's not going to make too much of a difference if you say it's 16. Does that make sense? Where, so where the 45, that 0.45, that's kind of like right in the middle, right? And so if you have multiples of that, that can add up, right? Where this is always going to end up being close to 16. So does that make a little more sense to you?
Yeah.
Okay. Well, since we're kind of struggling with the tension, we will finish this up tomorrow. We'll finish this up tomorrow and we'll finish up chapter 9. Okay, both of those are going to be on the exam. So since we didn't get through everything today, we're definitely going to be finishing it up tomorrow. Okay, I'll talk to you guys tomorrow. Have a good day. If there are, wait, first, are there any questions? Any questions? Okay. So then I will see you guys tomorrow then.